To another math video. Today in geometry I'll show you how to do lesson 8.1. I'll give you some practice and I'll go over some with you, some examples. So this lesson is going to be about 8.1 similar polygons. You all know what polygons are. And shapes that are connected with straight lines and have a number of sides. You have to have 3 plus sides. Alright, so in this examples 1 and 2, we are asked that the polygons are similar. We are asked to find the value of x. So, these polygons are similar, which means their scale factor is constant. The ratio of them, basically. Alright, so what we're asked to do is we have to find the value of x. Oh, what did I do? Alright, so we can set up a ratio, or what we know as a proportion. So, since this polygon is similar, the length of JL divided by the length of PQ equals the length of LK divided by the length of QR. Or, you don't have to do it like that. You can do X, or JK, divided by PR, which is 20, equals LK divided by QR. As long as their sides are corresponding, are in the right position, then you're okay. But for here, I'm going to do length JK, which is X divided by, I'm going to zoom in. Yep, X divided by LK, okay, 18 equals, now we have to do the other side that's corresponding to X. What is it? 20 equals 20 divided by, now what's the side that's equivalent to LK? Not equivalent, corresponding to LK, it's QR, which is 12. Now let me make this bigger. Now that we got our proportion, we can solve for x. What I want to do is to cross multiply. So 12 times x will be 12x, and 20 times 18 is 380. Let me just check that, sure. $360, I mean. Yeah, sorry, 360. And now we can solve for x by dividing both sides by 12. When we divide 12 over 12, you get 1. You all know this from the equations videos upstairs if you saw it in my videos. 360 divided by 12, what is that? Let me do that. 360 divided by 12 is 30. So that means the length of x is 30. That's our first problem. Let's go to the second one. Same thing here. Let's set up a proportion. Alright, here, if you notice, they're not facing the same way. One is oriented the other way, or it's reflected. So we gotta pay attention for that. So let's do x, or DE, divided by, let's do some length here, let's do 16, equals, now, if you look here, x is the longest side. So what's the longest side in this triangle? 18, or HJ, equals, look at that, 18, divided by, now, DF is the shortest length. What is the shortest length here? GH, which is 12. Okay, so now we can multiply 12 with x to get 12x, and 18 times 16, which gives us 288. Alright, now we can get that x is equal to 288 divided by 12, or 24. So in this example, the length of x, or the length of DE, is 24. Now that we know how to find variables in similar polygons, let's go to our next one. In exercises 3 and 4, the two polygons are similar. The perimeter of one polygon and the ratio of the corresponding side lengths are given. We're asked to find the perimeter of the other polygon. And I wrote down a little ratio or formula that will help us. So the perimeter of the smaller polygon divided by the perimeter of the larger polygon equals the ratio. And remember, this only works when the ratio is 1 or the ratio is less than 1. So, or at least for these examples. So here in number 3, we have that the perimeter of the smaller polygon is 48 centimeters. So I'm going to write that, 48 centimeters, divided by the perimeter of the larger polygon, that's what we don't know. Let's call it P, equals the ratio. The ratio is 2/3. And here, we're going to same thing. We're going to cross multiply. So, we get 2 times P, or 2P, equals 48 times 3. On the moon to do that. 144. Now, we can get that P is equal to 144 divided by 2, or 72. So, that means the perimeter of the larger polygon is 72, and don't forget units, centimeters. Now, let's go to the next one. This time, here, we're given the perimeter of the larger polygon, which is 85 meters. Oops, I meant to write that at the bottom. So P, let's say P here is going to be the perimeter of the smaller polygon, divided by the perimeter of the larger polygon, or 85 meters, is equal to 2/5, or the ratio. Alright, let's cross multiply. So 5 times P is 5P, equals 85 times 2, or 170. Oops. There we go. Alright, now that we got that, we can divide both sides by 5. To get that, P is equal to 34, or the perimeter of the smaller polygon is 34 units meters. Alright, now that we got that, we have a word problem. Yee. So modeling with mathematics, a school gym is being remodeled. The basketball court will be similar to an NCAA court, basketball court, which has a length of 94 feet and a width of 50 feet. The school plans to make the width of the new court 45 feet. Find the perimeter, that's what I should say, of an NCAA court and the new court being built in the school. So same thing, let's set up a proportion. So, now that we know, it doesn't matter like which way you do it, width divided by length or length divided by width, as long as you put the proportions the same. Alright, so let's do the length divided by the width, which is equal to the new length divided by the width. So, let's first, 94 feet divided by, what's the width? 50 feet equals, now we know that we don't know the length of the new court. Let's say L divided by the width of the new court, 45 feet. So we get, not TL, is equal to 94 times 45 divided by 50. Let's do that. So 94 times 45 divided by 50. We get 84.6 feet. But we're not looking for the length. We're looking for the perimeters of both courts. Okay, now that we know the length and width of both courts, let's apply the perimeter formula. It's 2 times the length, or in this case, 2 times 94 plus 2 times the width, which is 50. And doing that, we get 288 feet. Now that is the perimeter of the NCA court. Alright, now that we know that the width of the new court's 45 feet and the length of the court is 84.6 feet, 0.6, we can do 2 times those two values, so 45 times 2 plus 84.6 times 2. We get 259.2 feet. That means the perimeter of So that means 259.2 feet is the perimeter of the new court they're building in the school. Now let's go on to something else. In exercises 6 and 8, the polygons are similar, as always. We want to find the area of the other polygon. First, let's find, we know that the area of polygon, or rectangle in this case, 1, is 27 feet. Now, to find the length, we need to figure out 27 divided by 3, or 9 feet. That is the length of this first rectangle. Okay? Now, as you see, let's make a scale factor. Let's figure out the scale factor. So, from 3 to 6, we doubled the width. So the scale factor is 2. So, now that we know that the width is equal to 3 feet and the length is equal to 9 feet, that means if we multiply 3 times 2 and get 6, so the width of the new is equal to 6 feet. If we doubled the width, we have to double the length. The length is 9 feet, so that means 9 times 2, which is 18 feet. Now, to figure out the area of this, we simply multiply 18 times 6, which is equal to 108 feet. So 100 feet is the perimeter of the new rectangle. Sorry, area, whatever. Area of the new rectangle. Feet squared, missing that, feet squared. Now let's do one more example. Here we have a triangle. Same thing, we're still figuring out area. This time, and the same thing, we already gave in the area of the smaller one. So the area, let's write the area of a triangle formula. What is it? So the area is equal to 1/2 times base times the height. Alright? So what we need to do is figure out the missing dimension right here for the other side. So let's plug these measures in. So 10, or the area, is equal to 1/2 times 4 times L. Let's say L. Actually, let's say H, yeah. So that means, let's simplify this. So that means 10 equals, let's actually simplify it a bit further. Let's multiply both sides by the reciprocal. So the reciprocal of 1/2 is 2. So we got to multiply both sides by 2. If you do it to this side, that will cancel and become 1. Doing it to the other side give you 10 times 2, or 20, equals 4h. So that means the height is 5. So the height of this triangle for the first one is 5 feet. Now let's find the area. So we're already given that it went from 4 centimeters and it tripled to 12 centimeters. So and now that we got the height is 5 feet, we need to triple 5, or 15. Now the new area is going to be 15 times 12, which is equal to, do that, 180. Now 180 divided by 2, since it's a triangle, is 90 feet. Sorry, not feet. I don't know why I'm saying feet. Centimeters squared. So it's 90 centimeters square is the area of the second polygon, second triangle. Now I have one more here. So this time we're trying to figure out the area of the smaller polygon. So the scale factor is gonna decrease in this case. So the area is equal to the length times the width. We're given the area as 100. We'll add the units later. 100 is equal to 20 times W, or the width. So that means the width is equal to 5 inches. And the length is 20 inches. Now, what did we get from 20 to 4? We divided 5. That means our scale factor is 1/5. Alright? Now, 5 divided by 5, which is a width, the width divided by 5 equals a new width. So the new width is equal to 1. Alright? Now the area is simply 4 times 1, which is equal to 4 inches squared. So 4 inches squared is the area of the smaller polygon. Alright, now in this last question, we have a word problem. And if these videos are helpful, please like this video and subscribe to my channel for more stuff. Now, drawing conclusions. In a table tennis, the table is a rectangle that's 9 feet long and 5 feet wide. A tennis court is a rectangle that is 78 feet long and 36 feet wide. We're asked to figure out if the two surfaces are similar. Well, for the surfaces to be similar, the scale factor has to be the same for each length and width. So, think about it. So the length of the table tennis is 9 feet, and the length of the tennis court is 78 feet. So we're going to figure out. We're going to do 78 divided by 9 to figure out the scale factor, which is 8.666666666. So scale factor of length is equal to 8.66667. Now, to figure out if this is similar, if these two tennis things are similar, we want to see if the scale factor of the width also equals 8.66667. Otherwise, it's not similar. Or the table tennis is not similar to the tennis court. So the width is 5 feet, and then it became 36 feet. Now think about it. If you multiply 8.66667 times 5, do you get 36? No. So 5 times 8.667 is not equal to, let me use that symbol, not equal to 36. That means that no, the two surfaces are not similar because their scale factor isn't constant. That's it for this video. I'll see you for the next time. Peace, and please like this video.